Hi, in this video we will talk about sampling. Sampling is an activity that we do a lot in life. For example, when you go to a store and you want to buy some cheese, let's say half a pound of cheese, and you see a cheese that you've never tried before, do you go in and get the entire wheel and eat it? No, of course not. That would be silly and very expensive. What we do instead is we ask for a sample. That is a little piece of that cheese that we are thinking of buying. And that sample alone will be enough to tell us if we like the cheese or not. So today we will talk about sampling in communication research, and that involves in most cases sampling people, although sometimes we can sample objects or messages. And specifically we will talk about what a population is, what a sample is, and then we will discuss the non-probability sampling methods and the probability sampling methods. So let's start with defining a population. This is a term that we will oftentimes use. A population is all the people, objects, or events that have particular characteristics or of interest to a researcher and that the researcher wants to study. For instance, many researchers study college students. They study how media influences college students or how college students start and develop relationships such as friendships and romantic relationships. Of course, if you think about all of the college students in the United States alone, that is going to be a huge population. And that's why we do not work with entire population. It would simply be impossible to make everyone who belongs in a given population of people or objects or events participate or be a part of the study. It would take us too much time to gather those people or those events. In some cases, people would simply refuse, or objects, such as, for instance, documents, might be unavailable for access. Therefore, we sample. So a sample is simply a subset of cases, that is, people, objects, or events, that are chosen to represent a population. And if we pick a good sample, that sample is enough to tell us about the characteristics of the entire population. And today's video is just about that, choosing the sample. So we will begin with non-probability sampling methods. These methods do not involve the rules of probability, and the researcher does not need the sample to be highly representative of the population with mathematical accuracy. All of the non-probability sampling methods, in fact, are based on the principle of convenience. We select the sample based on whatever cases or people, objects, or events are available. And so we have four types of non-probability sampling methods: convenience sampling, purposive sampling, snowball sampling, and quota sampling. Let's talk about each of them in turn. The most basic type of sampling is called convenience sampling. What we do in this method, we simply select a group of people who are most readily available. Examples would involve standing in the middle of a street, or perhaps that's a bit risky, but on a street corner, and asking people to participate in a survey. Now, note, this does not mean that we talk to random people. Random is really not the right word, because oftentimes we will approach people who look friendly, not intimidating, or people will approach us by themselves. So we simply approach people in the street or in the mall. Another example is oftentimes researchers go into college classrooms and they will ask students in different classrooms to participate in their studies. So they are simply picking up whoever is available to participate. That's why it's called convenience, because it is convenient. And almost any group of people will do. And we use this method when probability sampling, the more sophisticated, mathematically grounded method of sampling, is just too difficult or too expensive to carry out. Now, of course, the risk with convenience sampling is that your sample may not be very accurately representative of the population you're studying. So if you want to study college students, but you only go into one large psychology classroom in one university, are those people going to represent all of the college students in the United States? Of course not. And that's the weakness of most convenience type methods. But let's talk about all of them. The next type of non-probability sampling is purposive sampling. Purposive sampling is used when we need cases with very specific characteristics and we hand pick those cases. For example, let's say that I would like to study the concept of motherhood. In other words, I want to understand what it means to be a mom. And I want to hear from different kinds of moms to get the most diverse set of experiences. So, I might want to sample a teenage mom, a stay-at-home mom, a working mom, an adoptive mom, a late mom, that is somebody who had a child late in life, a single mom, and so on and so forth. So I would handpick these women, look for specific people that would fit the different characteristics or different types of motherhood to get the greatest variation in my sample. That is called maximum variation sampling. Sometimes we also pick cases for purposive samples that are very different from the average, that are particularly unique or extreme. For example, if I am writing a book about public relations crises, that is, in difficult situations that happen in companies, I might go into historical records and newspaper records and look for particularly extreme types of crises so that my readers can really learn from good examples. When we look for extreme examples of things from the population, it is called the deviancy purposive sampling, because the criterion is deviancy or extremeness. So, for instance, the most recent crisis in the Toyota company with all the cars that have been pulled from the market, which is costing the company lots of money and reputation, would be a great candidate for my book on public relations crisis, and I would definitely hand pick that example for my book. So once again, purposive sampling involves hand picking the cases, examining every individual, not just picking anybody or anything, but carefully thinking about every single part of your sample, every single case in your sample, person or object or event, to make sure that you have specific type of sample, either a very diverse sample, that is maximum variation sampling, or a sample of very extreme cases, that is deviancy sampling. Next, we have snowball sampling. Sometimes we are interested in studying populations that are very difficult to reach. The access to them is limited, but members of the population are connected through a social network. A good example of this might be somebody interested in studying former prostitutes. People don't go out with a badge, "I used to be a prostitute," on their sleeve. So it would be very difficult to locate such individuals. But what we know is that oftentimes former prostitutes know other former prostitutes because they are just connected through social network from work, and so it might be very easy to get referrals to other people like these folks. Another good example of a population that might be hard to get would be families where one person suffers from a particular rare disease. For example, let's say children, we want to study families of children with Asperger's syndrome, which is a type of autism. Typically, people who have kids with this kind of syndrome are connected to other people for support who have the same kind of disability in their family, and so they know each other. Another factor here is the issue of trust. Oftentimes, these difficult to reach populations are also hard to get into because they do not trust people from outside. So having someone on the inside who will introduce you, the researcher, to additional people from the group who might be interested in completing your study is a very big advantage. So what happens is your sample grows like a snowball through referrals from people who already completed your study to new people who might be interested, and in turn those guys, after completing your study, might refer you to further people. So all you need to do in snowball sampling is initially find access to just a few cases, just a few people, and then from there on, move on, ask them for referrals to further individuals. And the last type of sampling is quota sampling. We use this type of sampling when we want to make sure that certain categories or groups are well represented or adequately represented in the sample. But we do not have what we call population frame or sampling frame, that is a list of the entire population, and we will talk about this concept in a little bit when we talk about probability sampling. But we want to make sure that, for example, our sample accurately represents the population in terms of a gender breakdown or racial breakdown or age breakdown. For instance, we want to make sure that our sample of college students has 51% women, 49% men, just as it is in the general population. What we do to obtain a quota sample is first we determine what are the percentages of our categories of interest in the population. So for instance, what are the percentages of men and women in my population of interest? What are the percentage of different racial groups in my population of interest? What are the percentages of different age groups in my population of interest? Once I know what they are, I go ahead and select the needed percentage from each part of the population. But of course I can do it using the convenience sampling method. So let's say I have a sample of 100 people that I want, and my sample will have 51% men, that is 51 men, and 49% women, that is 49 women. What I do is I just go ahead and grab the first 51 men I can get my hands on and the first 49 women I can get my hands on. So it's still convenience based, but the proportions of men to women are the same as they are in the population. So sometimes researchers have good reasons to make sure that specific groups, because these groups may be somehow sensitive to the research design, are represented as they are in the population. A good example is political research. Oftentimes, when we study issues related to party affiliation, like views on different issues, for instance, or support of candidates, variables like gender, race, and age, all of those variables are important predictors of your political attitude and your party affiliation. So it might be important for political studies to have accurate gender, racial, and age breakdown for your sample, even if your sample is just a convenience sample. So these four are the methods of non-probability sampling. The main weakness of all of those four methods is the fact that they are based on convenience, and that involves sampling bias. That is, you may, not even knowing, select people using some biased approach. For example, if you're approaching people in the street, you may only approach the people that are not intimidating, whereas all those that look a bit menacing, you might just not think of approaching, and so you're not really getting a very representative type of sample. And in terms of quantitative research, because quantitative research uses statistics and laws of probability and assumes that the sample is accurately representing the population, convenience samples are not the best choices because they do not give us those accurate representative samples. So let's talk about the probability sampling methods. There are four of them: simple random sampling, systematic sampling with a random start, stratified sampling, and cluster sampling. Probability sampling assumes that every member of your population has an equal chance of being selected into the sample. So going out into the street and accosting random people really isn't probability based, because if you are trying to pull people for your sample for a study of Westchester residents, and you go on Gay Street and you sample people from that street only, you certainly do not give every resident of Westchester an equal chance of being in your sample. So how do you do this? A good way of talking about ensuring that every member of your population has an equal chance of being selected is by looking at the first method here, the simple random sampling. So random means, again, that every member of a population has an equal chance of being selected into the sample. And what we need for this is a valid sampling frame. A sampling frame is simply an available list of all of the members of your population. A great example of a good valid sampling frame is the sampling frame of Westchester University students. The university has a list of all of the students enrolled in a university. And that list is accurate. Every person who is attending the university is on that list. If you can get your hands on that list, you have a perfect sampling frame. It's a valid sampling frame because it includes every member of your population. On the other hand, when you go any bigger, for instance, when you look at Westchester as a town and you want to get a valid sampling frame of the residents of Westchester, so not only college students, but anybody who lives in the borough, that complicates things. Because if you think about it, there probably isn't a single document that lists every resident of the town. Of course, we have the driving license records. Perhaps those might give you an accurate listing, but you probably may not be able to get your hands on it. Another possibility is looking at the telephone book. Is it valid though? Think about it for a moment. No, it's not very valid. The phone book does not include people whose numbers are unlisted because they choose not to be contacted. It doesn't include the people who do not own a stationary phone, only have a mobile phone like me. It does not include people who do not have a phone at all. There might be a few people like that. So it only includes a certain section of the population, but not the entire population. So if you do have a valid sampling frame, you can use simple random sampling. So once you have all of your members of the population listed, you need to number all of the members in your population and then use either a computer or what we call a random numbers table. That is something that, it's a table that contains a listing of randomly generated numbers, and you can use it by tracing your pen alongside it to simply select random digits and define then the corresponding members of the population in your sampling frame. But probably the easiest thing is to let the computer randomly select numbers from your population. And I have an example of a program that is wonderful for using for such a purpose. It's actually an online application. If you click on www.randomizer.org, it takes you to a website that allows you to draw random samples. If you click on randomize, let's say I want a sample of 25. So I want to have one set of numbers with 25 numbers in them. And let's say that I have a sample of all of the students of Westchester University. So there's probably about 14,000 students. So let's say that my number range is 1 through 14,000. And I'm assuming that I have a list of all of the students and they're all numbered. I wish each number in the set to remain unique. That is, I want every person to be selected only once if they're selected, so that I don't have any repeat numbers. And yeah, let's sort the number from the least to the greatest. And let's randomize. And we're going to now pull a sample of 25 cases from 14,000 in my sampling frame. Here you go. These here are the numbers corresponding to specific people who are listed in my sampling frame of Westchester University students. Of course, this is all hypothetical, but we could do this. So what is happening here is I am not choosing the people by hand. I'm not deciding who's going to become part of my sample. Instead, the computer is using random selection, and it's ensuring that every member of the population has an equal chance of being selected. Remember, this is only possible when you have a valid sampling frame that actually lists every member of your population, because if you skip at least one person, then you can no longer say that every member of your population has an equal chance of being selected into the sample. Another option of selecting cases is what we call the systematic sampling with a random start. Once again, you need a sampling frame for it. You pick the first case at random, and you can just let the computer do it, or you can use a randomizer.org just to pick one single random case. And use that as a starting point in your sampling process, and from there on, pick every case from that point on down the list. That means that you might pick every 10th or every 15th or every 20th case from the list. And that interval of every how many cases you pick a case is called the sampling interval. And it is calculated based on the size of your population and the size of your sample. So let's say if my population consists of 1,000 cases and I want only 100 cases from my sample, and I want to use systematic sampling with random start, my sampling interval will be 10. Every 10th will be selected from the population from the sampling frame, and that will give me 100 numbers or 100 cases. And sometimes we use this method, although, if you do have sampling frame, valid sampling frame, then typically simple random sampling is preferred. The third method is stratified random sampling. It's not necessarily an alternative to simple random sampling or systematic sampling, but it's sort of an addition or a more sophisticated method that adds one additional element on top of everything else that's done there. If you remember quota sampling from the non-probability sampling methods, this is a very similar method. We use this method when we again want to select subgroups that we want adequately represented in the sample, such as gender, race, and age. And I already talked earlier in this video, sometimes, for instance, during political research, the researcher really wants the different gender, race, and age groups to be adequately represented in the sample so that the different political views of people are reflected. Now, in this case, we don't use convenience as we did in quota sampling. In stratified random sampling, we use, of course, random selection. So we need the sampling frame. Then we organize our sampling frame by subgroups. For example, we can split our file with, for instance, Westchester University students into men and women, or into different college years, freshmen, sophomores, juniors, seniors, or into different racial and ethnic groups. And then from each sections of this organized sampling frame, we will pull appropriate numbers of students that are going to form appropriate percentages inside the sample. So once again, this is just adding a notch of sophistication to random selection. It is adding further possibility that our sample is really accurately representing the population. And this is really important in some types of research, especially research dealing with politics or current events. In those cases, we really want certain types of groups adequately represented as they are in the population. And finally, cluster sampling. Sometimes we don't have a sampling frame. It's extremely difficult to obtain a sampling frame because it would take forever to assemble it. It's possible, but it would take a long time. And so if we can't get a full sampling frame, we can cluster or place our sampling process in stages. So we can get the sampling frames of the clusters of the population. So what we do in this case is we list subsets of the population of interest, and then we randomly pick cases from each subset. Let me illustrate it. Let's say you are interested in collecting a random sample, a national random sample of elementary school students. Now, it would be extremely difficult and counterproductive to find and locate and create a valid sampling frame of all of the pupils in elementary school in the United States. That would take you forever, and by the time you finished, half of those folks will be out of school already and new ones would be in. So that definitely is not a good idea to use a simple random sample for a study like this. What can we do then? Well, we may not be able to randomly sample all from all students in the United States, but we could easily randomly sample from clusters of students in the United States. And such a great example of a cluster is a state. Every state is a cluster or grouping of a large number of people. And there's 50 states in the US, and you can very easily obtain a valid, perfect sampling frame that is a list of all of the 50 states. You can randomly select, let's say, 5 states from that list. Then from each of those 5 states, you can randomly select cities. It's very easy to obtain a list of cities or maybe counties in every state and randomly sample those counties from each state. Then, from each county, it will be very easy to obtain the list of schools and have schools sampled randomly from every one of those counties. And finally, from each school, you can then approach the schools and ask for permission to randomly sample the students. And in that case, if a school does give you permission, you can get probably access to the perfect sampling frame for all of the students, the listing for all of the students, and randomly select your cases from there. So just to summarize what we did is, because it would have been extremely difficult to build a valid sampling frame of all of the students in the United States, we created a valid sampling frame of all of the 50 states. We pulled a few states randomly from that sampling frame. Then in each state, we obtained valid sampling frames of counties. Then from each of those, we selected just a few counties randomly. Then for each county, we obtained a valid sampling frame of schools, and we selected just a few schools from each of those randomly. And finally, within each school, we can obtain a valid sampling frame of the students and sample those students randomly. So cluster sampling is a random sampling that is sort of multi-stage, and it goes around the issue of getting a valid sampling frame for the members of your population. So these were the 4 probability sampling methods. And now we talked about what a population is, what a sample is, what the non-probability sampling methods are, and what the probability sampling methods are. And I'd like you to move on to the activities in this chapter of Blackboard and complete them to apply this knowledge. A really good idea before you do so, though, would be to also complete the readings assigned for this section of the class. And as always, if you have any questions for me or if anything is unclear, just email me.